Okay. So I had a little problem trying to find the right scatter plots and regression plots. What did you guys do?
I only got halfway through because I had that 62-page paper, so I have to do all my work tonight.
Okay.
Oh.
Well, if you can understand it, it's not too bad. So let's go through. Number
Is it
one.
mostly just going through the 4 things to make sure.
Yeah, they ask a few other little questions, but mostly it's just adding on to what we did last time.
Okay.
So number one is give the equation, and it's y hat equals BO plus B1 x.
Mm-hmm.
And then the other equation is y equals capital BO plus capital B1 with a little e.
Epsilon.
Oh.
Epsilon. It's the first equation is the estimated linear regression equation, and the second one is the true linear regression equation.
Yeah.
Okay.
So there, and says what are the requirements to check when doing linear regression? How do you check for them, and how can you tell that the requirements are met? So there's a linear relationship by looking at the scatter plot, looking for a hot dog shape.
Correct.
Funny how that word came up the week after we had a quiz on it.
Mm-hmm.
It has a constant variance by looking at the residual plots, no megaphone shape. And the error term is normal by looking at the QQ plots that looks like a shotgun blast. Okay.
Correct.
Okay, so then we're supposed to check the requirements for the cheese. So, Ricardo, do you want to tell us how you do your X and Y? Because
yeah,
that's what I didn't have a problem with. It was one of the others.
There is always a cue that we must be very careful. And normally it's the last part, and I highlighted and I with this I can choose correctly the two variables. In this case, is the last phrase that says we want to predict quality of taste. So predict, it's a dependent variable. It's dependent for the lactic acid. So
keep going.
So the predict, it's always the y, correct? It's dependent.
Yes.
And the concentration of lactic acid is the X because it's independent.
So the X is independent.
Yes, the X is independent.
No, it's the dependent. So X.
No, X don't depend.
X is independent. It does its own thing. It doesn't matter.
It's it. Yes, independent. What I said it wrong?
No, you didn't.
No, I've had it wrong in my head. I have it written down
wrong.
Okay. So independent, it's the predictor.
No, it's
the
explanatory variable.
Oh, sorry. Y is the predictor.
Mm-hmm. Y, predict. We want to predict Y. Predict Y, predict Y. That's what I have in my mind.
Smart.
Okay, and independent is the response.
Mm-hmm.
No, dependent is the response.
Yes, dependent. No. Dependent is the
response.
It's dependent. It's what you want to predict is dependent. Okay.
So independent is the response?
No. Dependent is the response.
Okay, so Y is dependent and it's the predictor and it's the response?
No.
Uh,
Yeah. Okay, y is the dependent variable or the response variable? X is the independent variable or the explanatory variable?
Anyway, I just memorize this. If you want to predict, it's always y.
Okay.
And the other guy, it's x. Okay? The other guy is x.
I have to write it down. I have to see it. I have to put it. Okay, you're a predictor. So I got my independent mixed up. So X is independent. Y is dependent.
Yes.
Okay. Okay. So for my scatter plot, I have lactic acid on the bottom and taste on the side.
That's correct.
Okay. Well, I think I did this one right for some reason. And my scatter plot was okay.
It's like a hot dog shape.
Yep. And then
Correct.
my scatter, that was my scatter plot. And then the residual plot, it looked fine as well.
And no pattern.
No pattern.
Mm-hmm.
And then the QQ plot was fine as well.
Yeah, you have like a line with points are very close to the line, correct?
Yeah, I did 2 different QQ plots. So maybe
you have to use.
I did a normal. I did the
Normal?
observed value and deviation from normal on standardized residual QQ plot.
But I think that what they want is the expected normal value.
Right, and I got it. I redid it. I've got that one there
You
too.
got it?
Yeah.
Okay.
Okay, so I got the coefficient was, I got all those, I think I got all those numbers right, 0.704.
Yes, the R, correct?
Yeah, and then the number 5, y equals negative 29.859 plus 37.72 x.
Correct, x. Mm-hmm.
Okay, and then number 6 is 49.73026.
So in this case, I have to review it, but I know now how to do it.
Okay, yeah, I wrote step by step.
Yeah, you need to put the number on the SPSS on the last available cell
Run the
on the column. And then you must analyze again and run
the unstandardized something
yes,
on the
that's
right-hand side or the left side.
Mm-hmm.
Okay. Number 7, find and interpret a 95% confidence interval for the slope of the regression line obtained when lactic is used to predict taste. I had 22.999 and then 52.441. And so
that's it.
And this still doesn't make sense to me. We are 95% confident that the slope of the true linear regression line of lactic with taste is between 22.999 and 52.441.
Yes.
Doesn't mean anything to me. Okay, so then we're going to do a hypothesis test for all that information. And our hypothesis, luckily the hypothesis, this is really easy. HO is B1 is equal to 0, and HA B1 is different than 0.
And it's always like that in this case.
Yeah. So the test statistic was 5.249.
Correct.
And the p-value was 0.0001405.
1.14, yeah, which is almost 0.
Right. I don't know why we wouldn't have just rounded that to 3.
So we reject the null.
Right. So there's sufficient evidence to suggest that the slope of the true linear regression line does not equal 0. We conclude that there is a linear relationship between the concentration of lactic acid in cheese and the quality of taste.
Which is interesting. So probably with more acid, the quality of taste differs.
Yeah. So, okay, do you want to take the next one? The Prius?
Yeah, if you go to the last phrase, you want to predict price based off of mileage. So which is the X and the Y?
Price is the Y and X is the mileage.
Correct. Predict
So,
Y, mileage, the price is the Y, mileage is the X.
right. So I got that one fine.
Okay. So
And then I had trouble with my graphs on this one.
so the scatter plot, you have mileage on the X and price on the Y, correct?
Well, I have something residuals, so I did the wrong one. But
and then when you do the scatter plot, what we have is that we don't have a shape. It's not a very, it's a different, it's not hot dog shape or whatever. So we conclude that there is no significant linear relationship. Okay.
okay, no. Okay.
Because we cannot conclude this because the shape is very like a blast, you know.
Right. So what did you do for?
And then in the scatter plot, you conclude that. But in the residual plot, we have no pattern. So, and that's okay. For the residual, no pattern, it's correct. But you continue because you just conclude that the scatter plot does not seem to show a significant linear relationship, and it's true. No hot dog or whatever.
Okay, and I got all the right. I got all the right answers on the rest. I just had a problem with my graphs on that one.
Okay.
So.
And what about the Kiki plot? Did you do it?
Good. It was everything was coming up wrong.
Probably because you need, if on the Kiki plot you have the observed value in the X and the expected normal value on the Y, and it's a line very, and you can conclude that this plot is okay.
So observed value on the X and what's on the Y predicted?
Expected normal value. You must do an unstandardized residual first.
I did that, I think, but I did something wrong.
You don't change anything on the X. You maintain X with the mileage, okay? You only change them the price on the Y with the new value, I don't know the name. That name.
I know what you mean.
Okay. And standardized or something like that. And you change it when you're going to calculate
the QQ.
Even to the residual plot, you must do that.
Okay.
You must do that for the residual and for the QQ plot.
Okay. Well, I must have done it right somewhere. I didn't do it right on this one. Okay.
Okay.
So, I'm going to 14.
Yes, Y is 25,838.626 minus 0.034x.
Okay.
Then in 15, you change the miles, 100,000 miles. You change it on the column, and the program calculates the Y, 22,401.192.
Okay.
For the next one, you must change the 95% confidence interval
To 90.
to 90. And you have minus 0.073 and 0.004. It's the confidence interval. So we are 90% confident that the slope of the true linear regression line of lactate with taste is between minus 0.073 and 0.004.
Okay, I got all those numbers right.
Yes?
Yep.
You have the null and the alternative. It's the same as the previous one. The t is minus 1.476. The p-value 0.144. In this case, the p-value it's higher than the 0.05, the level of significance. So we fail to reject the null. But
Yeah,
the conclusion is it's very difficult to do it. So I just copied by the I copied by the answers the key answer. We conclude that there is not a linear relationship between the mileage of Prius listed for sale and its price. And that's conclusion.
right.
Okay, that's important. There is not a linear relationship.
Okay, so I'll take the next one, the lead exposure. So this one at the bottom says, researchers want to predict the BRS rating. So I thought that was the Y for sure, but it wasn't.
No, it is.
But I put it in the Y, I got all the answers wrong.
It's the Y, predict. Huh?
And you got all the right, because I put it in with BRS as my Y and lead levels is X, and I did not get the right numbers.
But I did it. I did. The Y, it's the predict, okay? So I put on, yeah. And then I got, the R is minus 0.181. It's the...
Well, I got all the right answers when I put it in the other way. I'm trying to see, I'm going to pull it up again and put it back in. Just because this one was confusing to me. I thought I had it all figured out.
And no, it is, and you are right. Why it's the predict, always the predict one. And I did it, and my numbers are correct.
Okay, well.
R is minus 0.181. The equation for linear regression, it's 62.825 minus 18.235x.
Yeah.
Sorry, 236. 236. And then you calculate the Y for the blood level of 0.75 micro something, and it's 49.148. And then you do a 95% confidence interval, and I got minus 41.855 and 5.383.
Okay, I got that too.
And the p-value was 0.128, correct?
Yep.
So we failed to reject the null. So we conclude that there is not a linear relationship between a child's level of lead exposure and his or her behavior rating. So no problems with lead in this case.
Okay, I'm trying to pull up my SPSS to see if it's taking forever.
Okay.
So Jessica, you got all that?
No, I didn't get that far. I have to go back through when this is over and learn it for myself.
Mhm. Yeah, but when you put everything on the SPSS, you have all the results there.
It's just getting it in there the right way.
Yeah, I started to go through it and I wasn't having any trouble in the beginning, so hopefully that will continue.
Mhm.
I just had a hard time with this lesson comprehending the bigger picture.
Right.
I just don't get it.
Right. It took me like 3 days to get through this homework, working on it, little chunks at a time. So, okay, the last question. A scatter plot is made to test correlation between two variables. When residuals were calculated, one residual had a value of 4.5. What does that mean? So I had no idea. I had to look at the answer.
Yeah, it's you know, when you have you have the predict one and you have the real values, okay? And
So when we're testing the residuals, we're testing the actual.
the residuals is it's the difference, okay, between two values. It's between two variables. And when they say one residual have a value of 4.5, and if you go to the column of residual that you calculate on SPSS, you have a value, correct?
Okay.
And that value is normally the difference between two variables. So because it's 4.5, it's a positive, so it's a higher value than the predicted one.
It could be 0, right? We're predicting 0.
No, 0. But if it is a 0, we don't have any difference between the two variables.
Okay.
You have a negative value, you have a lower value predicted.
Okay.
The actual value is than the predicted value. You understand?
Yeah, it's still confusing, but
It's like you remember when we do that comparison of variables and we subtract one by the other.
right.
It's almost the same, okay? But in this case, it's a correlation between two variables. If it is positive, it's because the value is higher, the actual value is higher than the predicted value. If it's negative, it's above.
But it kind of threw me off because
Below, below.
Yeah, the test correlation, it says made to a test correlation. So that for me is the R value, and we have a strong positive correlation, or we have a weak positive correlation. So that would have been my guess, was the weak positive correlation between the two variables.
Ah, I understand. But that it's about the shape and the calculation of and you calculate an R. You remember?
Right. So I thought the 4.5 was the R.
But no, but the R it's always between -1 and 1.
Oh, that's right.
So it's not possible. 4.5 it's
That wouldn't work.
okay.
Thanks for clarifying. Okay.
One more week, Jessica.
Yeah.
One more week.
I know. That test is going to be horrible if it's comprehensive. Oh,
120 questions.
that's going to be awful. How many? It's only 40 questions, right?
The final exam, it says, oh, it's worth 125 points, I think.
Yeah, it cannot be 125 questions. I will die.
It probably is.
Probably 50 questions.
Oh, so awful.
So
Okay.
can we go to the homework quiz?
Yeah, group meeting quiz.
Group meeting quiz, yes. I was on the group meeting quiz, not the homework. Group meeting quiz, start quiz, okay.
Do you stop recording now?
No.
Okay, you keep it going.
Okay. I'll start, I guess. The true linear equation.
Oh,
You ready?
yes, I'm ready.
Okay, the true linear regression equation y equals BO plus B1x, where BO and B1 are unknown. What is the null alternative hypothesis?
It's the third one.
3.
3.
I'm gonna write all this down.
Oh, yeah.
Okay. A residual. Well, you just explained this to us, Ricardo.
So read it. Read it.
Is the difference between an observed value y and the predicted by the regression line.
It's the third one.
Yeah, so I just read
I think so.
Okay. A plot of the residual supports using linear regression when the residual looks normally distributed. I would say number A. Number 1, the residual looks normally distributed.
For the plot of residuals, the plot must be the plot. The plot, are we talking about the Kiki plot?
The plot of residuals.
And the plot.
We don't want to, they're not all positive, right? We don't want to see a megaphone shape.
The plot of residuals, we don't see, yes, no pattern. So, but the residual plot is to be of significance, must be with no shape or no pattern, correct?
Right. So that's got to be number 1 because all the rest have a pattern. Or you agree?
If normally distributed is with no shape,
Yeah.
yes.
The others don't fit, right?
No, the residuals are all positive. You see a megaphone. The megaphone, it's
Wrong. It's
no
bad.
for sure. You see a pattern. No, you don't see a pattern.
Okay. So
So,
1.
yeah.
Okay.
Oh, let's go to math self.
FSC.
Let me open my, okay. Let me open it. It's already open. And math. So let's read.
Hold on,
Let's
mine
read the.
forever to open.
So use the confidence variable as the explanatory variable and the score variable as the response variable.
Hold on.
So in this case, we don't have the same words. So
Okay.
so in your notes, the explanatory is the
Use the okay, explanatory. Let me look at my notes.
yes.
Explanatory is the Y or the X.
The X.
Okay.
Okay.
So use the confidence variable as explanatory. So
Confidence variable.
Gotta get my notes out. So we gotta find the residuals. So we're gonna analyze regression.
Yes, analyze.
So my dependent variable is
dependent,
score.
independent.
Okay, so the dependent is the score, right?
Yes.
And the confidence rating is the independent.
Confidence is the independent, and the score, correct?
Is the dependent.
Dependent, okay. Let's do already the, let's go and save it. I'm going to do it everything already.
Okay, I'm not doing the unstandardized because that's usually where they want you to put the extra number in first.
Okay, so
So residuals, unstandardized.
the first question is,
Okay, compute the residuals for the data using software. Which statement best describes the residuals?
compute the residuals. But we need to, okay, I already calculate the residuals, but we need now to see the shape of them, maybe.
Yeah, because I'm not seeing those numbers. Do you have negative 40 and 25 anywhere?
Let's see. Yes, I have negatives and positives on the residuals.
Where?
I already calculate on the new column. When you analyze it, I went to the save option and did the under standard, that thing. And I ran it, and I have already the residuals. Let me analyze it with a
Scatter plot?
Yes, let's see. Let's analyze it. So the x is always the same. The x is the, remember? The confidence, correct?
Yeah.
So the x is always the same. And now I'm going to change the y with this new column.
The unstandardized.
Yes, to see the shape of the scatter. See. Okay, it's a blast. So it's
Okay.
it's correct. So the let's see the options.
Well, it's got to be number one because the residuals don't form a linear pattern, and they're not all negative.
The residuals.
But I'm not seeing.
But
38.19987 and 23.4230.
Where are you
they
looking
are
at?
On the residual statistics,
mm-hmm.
is that what you got?
Actually they are between the most negative.
Yeah, I guess the residual, you got negative 38.
Yeah.
And 23.
Yeah.
So I guess that is correct, right?
I guess.
Yeah, that's a strange question, but
they're not all negative, and they don't form a linear pattern, and they do lie between those two numbers.
So the residuals are between about minus 40 and 25?
Yeah. Okay, based on the QQ plots. So now we have to run a QQ plot.
Can you think out loud when you do that?
Okay, we're going to run descriptive statistics down to QQ plots. And then our variables are the confidence rating and the unstandardized. Let me push OK.
So I'm sorry, are we on question 7?
Yeah, we're doing a QQ plot.
Okay, so let's do a QQ plot.
And then I came up like 5. Gave me a whole bunch of QQ plots.
I have two. I have the normal QQ plot of confidence rating mean, and then a detrended normal QQ plot. Oh yeah, I have those too.
No, but we don't need that. We just need the first one, right?
Yes. And the question is the QQ plot for the residuals. So it's for the residual column. So I have a...
So which one is that then?
It's the under standardized something.
Unstandardized residual?
Yes, that's the one.
Okay.
And we have the results are completely normal.
I think they're fairly normal, right?
Yeah.
The residuals are fairly normal. Correct?
Yeah.
Correct.
Now, 8. Use software to create a scatter plot of the data.
Scatter plot already, right?
Yes, so the residuals are normally distributed, correct? The linear relationship between both. We need to... Let's see, we need to do a scatter plot between both of the variables, and I think that we didn't do it yet, correct?
We did the confidence and the unstandardized.
No, but we don't have the graph, correct? Or we have
one scatter graph. We have one scatter plot graph.
We have from both variables?
No, I guess not.
No, we don't. So it's confidence and score. We need to do this. This is the original data. Score in Y, confidence rating on X. And we need to do a scatter and see if it is a hot dog shape.
And put the line in it?
With a line, yes, it is. We have a hot dog shape. And let's see the elements fit the line.
Okay, so yeah, it looks pretty hot doggish, kind of.
Yeah, it's a kind of. There's a dots outside of that we can consider that they are hot dogs. So there is a linear relationship between X and Y. That's the first one.
That's the answer.
Mm-hmm. We must check the first one. The third one, let's see the second one.
Oh.
The variance of the error term is constant for all values of X.
So how do I interpret that? I don't know the answer to that.
The variance of error, that's the epsilon, correct?
Okay, so how do we figure that one?
The epsilon, so they are constant for all values, I think so. Let's see, let's see if I have something here on my notes. The visual is different between to check all requirements for difference, we need to scatter plot the X and Y. We did it. A residual plot, a Kiki plot for the residuals.
Okay, so I'll go back to we have a linear relationship. We have to have constant variances. So that would be number 2. And we have to have
yes.
Error term is normal.
Yes, the variance of error terms is constant for all values.
Yeah. So the first 3.
Okay. Yeah. And the last 2 ones, the X without error. I don't think so.
Yeah, so just the first 3?
No. We have also a requirements. The X are fixed and measured without error.
Where does it say that?
I from the readings.
Okay, you've got that in your notes?
Yes. Precisamos virar para aqui.
Part of the 5.
Ah, voltou mesmo no meio.
So I don't have that in my notes.
In other words, the x's can be considered as known constant.
I can't hear you, Jessica.
Okay, I'll talk louder.
Okay.
So I think that they are the four, the first four options.
Okay.
The observations are independent. Yes, the observations are independent. I have it here in my notes too. Let's see, the requirements are, there is a linear relationship between x and y, and we did that. The error term epsilon is normally distributed. Third, the variance of the error terms is constant for all values of x, and we did it. The x are fixed and measured without error.
I don't have the bottom two.
And the observations are independent.
Okay, so all of them?
I think so.
Okay, how come I don't have those 5? I have the first.
They are.
It's at the very beginning.
They are on the
of
readings.
lesson.
It's what?
It's
Yeah.
at the very beginning of the lesson.
Correct.
That's where I found it.
Okay.
Yes. So what is the B1? The B1 is,
Okay, so we're saving all of them. Okay, 9.
I think B1 is the slope. The slope is the, let's see.
What's it? The 18,
0.690.
690.
I'm not seeing where my data is.
Coefficients.
Okay, I found it. So what numbers do you have on the B's coefficients?
I have 18.690.
And in the bottom 12.695, correct?
Yes, that's what I have.
Now what I think that we are the slope is the second one, correct? Let's look for my notes. Yes, the y it's B0 plus B1.
So it's 12?
So the B1 is the second one. I think so. It's the second one.
Okay.
I think you're right.
It's 12.695. 12.695. Construct a 95 confidence. I already did it.
That too. So the lower bound is 10.674.
Yes, 10.674. And the upper bound 14.715. 14.715. In 10 minutes, I'm going to leave for. I have to present a outline for my other course.
Then let's
okay.
hustle.
What
You
was
gotta
the-
hurry.
I'm sorry, what was 10 then? What was the lower bound?
10 was
The lower 10. Yes, please, Jessica.
What was it?
The lower bound 10.674 and the upper bound 14.715. Okay.
okay, number 12. Based on the evidence and using the significance level of 5, what decision would you make? So our significance levels really
Almost
small.
0.
So we
Yes.
reject the null.
Yes, we reject.
Right?
Yes, we reject because the p-value is less than
A.
the level of significance. Okay.
So there is sufficient evidence
that the slope of regression line is 0.
So number 2.
Yes.
There's, are you sure? Because if we, oh wait, we're not failing, we are rejecting.
Yes, because when we,
There is sufficient evidence to conclude does not equal 0. So it's got to be the last one. If I go back to the homework, when we have a reject the null hypothesis, the answer is there's sufficient evidence to suggest that the slope of the true linear regression line does not equal 0.
but it's not 0. Yes, it's not 0. It's the last one.
Last one.
Because 0, it's the null, but we are rejecting the null. You're right.
Okay.
0, it's the null, and we don't have. Then we reject the null. You're absolutely right. Yes.
Okay.
So 13 is 4.
Yes.
Okay, now I'm opening the crocodile.
Well, it says it gives us the answer right
Yeah,
here.
fine.
Head length was used to predict body length. So for question 14,
So head length
the dependent variable.
Head length is the x.
Yes, so body length would be the dependent. So 14
Yes.
is body.
Okay, hold on.
Correct.
Okay, so what was 14?
Body length.
Oh, I have to leave in 2 minutes.
Okay, let's hurry. I've got it open. We're going to analyze regression, linear. Okay, what do I put in my dependent?
Dependent is y, and it's the head length.
No, wouldn't that be the body length?
Yeah, dependent is the body
Now
length.
there,
Body length.
Yes.
yes, the
And
body length is
The
the
head length.
yes, the head is independent.
Okay.
The body is dependent. Correct.
Okay. So I've got determine the margin of error. So how do we determine the margin of error?
Oh, goodness.
Margin of error for the 95 confidence. Oh, the margin of error.
That's way back.
Ooh. We need to go back. Ooh.
Okay,
I don't remember the
lower
formula.
bound. So we need to subtract the mean from the lower bound.
Yeah, you always, that was your
Okay.
Where's the mean? 32. 328. Is that the mean?
I don't know.
3.89 minus the lower bound. 7.218. I got 321.672.
Okay.
You do it differently, Jessica? Could you do it differently?
I don't know. I don't have the information in front of me.
That's way back when.
Yeah.
So that's my notes.
Try your answer. I'll run it through first.
Okay, well, let's put that answer in and see if it's wrong.
Yeah, we'll just put the answers in those last few ones, and then I'll run it and see so that he can know.
15.
I'm sorry, but
Oh,
I have to leave.
okay. We
If you
got,
don't mind.
okay, 16, the lower bound is
The lower bound
7.2.
7.18.
18.
7.218.
And the upper bound
And
is 8.1.
the 8.103. 8.103.
8.103. So based on our lower bound and upper bound.
What did you say about B1? The B1 is 7.660.
I would say we are 95% confident the interval will contain the true value of B1.
Mm-hmm.
Okay. I'm going to submit it and see where we're at real quick, as fast as I can.
We didn't do it the 15, correct?
We did 15. I just put, I don't know if it's right.
And the result is?
321.672.
Okay, 15's wrong.
321.
Oh, it's wrong.
Okay, it's the lower bounds.
7.218
Minus?
minus the mean.
But we need to calculate the mean. The mean is where?
Well, I got the mean over here on the residual statistics, and I used 328.89.
8 and 15 are wrong.
Okay. My suggestion is that we can conclude this today, and then
Okay.
maybe we can share the results. You agree?
If we just miss one.
We missed number 8 and number 15.
8. Oh, it's not all.
Which ones do you think it's not?
It's just asking which ones we can see by these 3 graphs.
Ah, you're right. It's not all I understand. You're right.
So which ones do you think they are?
It's the linear. It's the first one, the third one,
I would say it's the first 3, because that's what I had in my notes. The requirements for linear regression.
probably.
I would say it's the first 3.
Okay, let's do it. Let's do it. I will change it later. Okay.
All right. Good luck on your presentation.
Thank you very much.
Yep.
Bye-bye.
Friday.
Bye. See you. Bye-bye.
Bye.
Bye.
Okay, hold on. I'm going to stop broadcasting.